Welcome to my video on the math of sound waves. Before you watch this video, it would be a good idea to watch my video on the characteristics of a sound wave using an oscilloscope. I will leave the link to that video in the description. As a quick reminder of the parts of a wave, let me remind you of this visual. Here's a sample of a sound wave. It has several parts. First, remember that the amplitude is measured from the midline to the crest, or possibly from the midline to the trough. Wavelength here is measured from trough to trough. It can also be measured from crest to crest, and you could also measure it from the beginning of a valley to the end of a hill. So there are all types of ways to measure a wavelength as long as you have an entire top and an entire bottom. All right. With that reminder, we have first to discuss the length of a wavelength, and how that affects frequency. So here you see the different wavelengths and the different waves of the colors of the rainbow. And you can see that violet has the shortest wavelength of 400 nanometers, and the color red has the longest wavelength of 665 nanometers. So those are the actual measurements of each of those colors. 400 nanometers for violet, 665 nanometers for red. And you can see the difference there. And the idea here is that the shorter the wavelength, okay, like for violet, the more waves that can pass per second. So if we isolate the violet and we isolate the red and we just focus on those two, you can see that there's a lot more waves in that section of white. So if we said that that section of white is a period of 1 second, we can say that there are 4 wavelengths per second for violet. All right? So every second, 4 waves go through. 4 full waves go through. That is called frequency. The number of wavelengths per second. So for violet, it's 4 wavelengths per second. For red, it's approximately 2.5 wavelengths per second, according to my graphic here. All right, so you can see that purple, there's a lot more waves per that section of time, as opposed to red, there's a lot fewer waves per section of time. So the shorter the wavelength, the higher the frequency. The longer the wavelength, the slower the frequency. All right, next we have a formula, the wave speed formula, and it's V equals F times lambda, that funny little symbol there. And that F is called something else, I forget, but it looks like an F, so, and it's frequency. So the V stands for wave speed, and you can remember it if you remember it V for velocity, right? The F, of course, is going to be frequency, and that symbol lambda is going to be wavelength. As a reminder, this formula is one of those science formulas that I've spoken to you about before. We can put it into a formula triangle, and we're going to be using that in my next example. So our wave speed formula is wave speed equals frequency times wavelength. All right, so here's our example here. A police siren has a wavelength of 0.50 meters and travels at the speed of sound of 343 meters per second. Determine the pitch of the siren. All right, so let's take a look at what we have here. We have the wavelength at 0.5 meters. We have the speed of sound All right, the wave speed of 343 meters per second, and it's saying that we want to find the pitch. And if you remember from the previous video, our pitch, or high or low the sound is associated with its frequency, right? The higher frequency, the higher the pitch. The lower frequency, the lower the pitch. And so when we plug in these numbers into the formula, we get the speed of 343 meters per second equals frequency times 0.5 meters. All right, hopefully you can recognize how I just placed that in there. Next, we can use the formula, or I'm sorry, the triangle, to figure out what formula we're going to use. And so it's going to be frequency. And if you look at the triangle, you can see that speed is over wavelength. So we're going to put the speed of 343 over the wavelength of 0.5. And so we get our formula of frequency equals speed over wavelength, 343 divided by 0.5. And grabbing a calculator, we end up with a frequency of 686 waves per second, which is another unit for that is the hertz. So frequency is 686 hertz. All right, so that's a nice rundown of the lesson about sound waves math. All right, thanks for watching.